I'd like to look at process paradigms for a minute before going on to how do we improve these processes. And the reason I want to look at the paradigms is because what we see depends how we look. And with something like a process which is not easily directly observable, it's usually constructed as some kind of a model of something. So we have various models of a process, and that directs attention to some aspects of what's going on as opposed to some other aspects. Now, all models do that to some degree. All models highlight some aspects of the situation and diminish others. Now, we wanted to do that because we want to bring out those things that are of interest at the time. Now, improving a process does depend on how you look at the process itself. So let's have a look at a few. The first one is the quality management paradigm, where with quality management, the whole organization contributes to quality in one way or another. Now, this was fairly well established by W. Edwards Deming in I think it was the 1950s. He worked prior to that, but it started to become come to attention in the 1950s. And he was preceded by other people, most famously Walter Shewhart, Joseph Juran. He himself was a pretty big name. He was followed by Philip Crosby, and there have been other contributors to the field since that time. But the whole idea is that the quality isn't just what's going on at the hands of the operator. There is a whole lot of organizational factors that contribute to the quality. But importantly, you observe the effects of things on the process in terms of its effects on the quality of the output product. Now, the objective is to reduce or eliminate faults in the development, and that results in a focus on the methods of transformation through verification and validation. A process performance variation is better dealt with by fixing the process and not the person, which contradicted what the previous belief had been, which was essentially that since I've specified it all wonderfully well, if it's going wrong, it must be the operator's fault. And that's just turned out to be neither true nor helpful. Now, ISO 9001, the major standard in product quality, is based on this paradigm that work is done through processes, and we need to examine the process itself, the whole process, and improve the whole process. Now, there is a production paradigm which is slightly different to the quality paradigm. The reason why this is important is because if you regard something as a production process, say software development, if you regard that as a production process, the whole idea with the production process is to reduce variation, to make things very, very repeatable. And defects arise from variations in the process. Those variations in the way the work is done, or variations in the input raw materials or input instructions, or timing events, things like that. And the whole idea is to reduce that variation and make things absolutely repeatable. Well, you can imagine something as varied as software development, how well this works. I mean, it does work to some degree in that software development, like everything else, you do need to get some basic processes under control. So that works. But beyond that, there can be a bit of a problem. Nevertheless, we have a lot of experience in the production paradigm, and a lot of the lessons are transferable, and so people do try and interpret software development as some act of production to some degree or other. CMMI and SPICE as process improvement methods are based on this paradigm. Now, in contrast, we have the engineering paradigm, where the whole idea of engineering is one of optimization. Now, I've said this to some people, and that they've picked me up and argued that engineering is actually very creative. Well, it might be, but the engineering paradigm starts with a specification. Now, how that specification gets there is a different matter, but they start with a specification. And the job of the engineer is to produce something as close to that specification as possible to get the optimal solution. that focuses on reducing difference between what was specified and what was developed or produced. And the results, this results in a concentration and defects of production. Now, it does require a reasonably clear set of specifications, and you can argue that, well, when the specifications are either incomplete or unclear, then the engineer has to be a fair bit creative to try and build something, which is true. Now, most software development methodologies are, in one way or another, based on the engineering paradigm. That is, we get the specifications, and somehow they're right. And you can see this going through ISO 12207 and ISO 15288. 15288 for systems engineering and 12207 for software engineering. There is a great deal of emphasis on developing the specifications and getting the specifications right, and then producing things according to the specification. Now, that makes a lot of sense when the project is big and you're dealing largely with dispersed teams, distributed development. Now, to go away from the product-centered approaches, we have the team management paradigm. And this is one where you assume that people are competent. You assume that they're on top of things, and we're simply going to manage the team. Now, these start by acknowledging that people make mistakes. The mistakes are classified as slips, errors, and lapses. And I won't go into the classification at the moment. But the team paradigm first started out in aviation, where it was referred to as the crew resource management. So what goes on in the cockpit to try and avoid some situations that led to pretty bad accidents. It's since migrated toward surgical teams, hospital teams, where it's having some success, not as much as we'd like, but some success. And I'm seeing or detecting an increasing number of publications and talks given roughly on the same topic, and that is, people are fundamentally competent. If they're not, you don't hire them in the first place, but they're competent. They do things for good reasons. And so we have a look at setting up an environment where we can find these mistakes, and we can expose the reasons for these mistakes, which are largely to do with the interactions between people than it is to do with any specific work technique or habit. And once we expose all the problems due to these interactions, we can address those problems and create an improved, more robust process to do things. So the summary for all this is that the process paradigm will determine what type of improvements can be made or can be detected and made. And the dominant paradigm of software development is the engineering paradigm, or you could say it's production paradigm, but one of those two. There isn't a perfect answer, but there are some spectacular results that can be achieved.